You want to become a data engineer? I get it, I get it. In this video, I'm going to be talking about the rise of SQL and what are its adversaries today. So structured query language, or SQL, has been the backbone of relationship databases for decades. Since its inception in the 1970s, SQL has evolved to become the dominant language for querying and managing databases. However, with the explosion of data and the diversification of data use cases, SQL is no longer the sole solution for managing information. Several challenges have emerged to address the limitation of SQL in handling large, unstructured and real-time data, and in this video we are going to be talking about the strengths of SQL in the modern competitors challenging its reign. SQL has remained popular for many reasons. First, for its maturity. SQL has been around for decades, meaning it's well documented and highly optimized. Second, the ACID compliance, which is the SQL databases like, for example, MySQL, PostgreSQL, SQL Server, Oracle servers. So all these technologies provide strong guarantees around transactions, ensuring data reliability and consistency. The third point here is the declarative nature. Users can specify what they want to retrieve without needing to detail the procedure for how it is retrieved. Next, we have the relational model, because SQL works well for structured data, where relationships between data points are clear and can be organized into tables. The fifth point about the strengths of SQL is the standardization. SQL is a widely organized standard, making it easier to learn and implement across different platforms. However, with the rise of web applications, cloud computing, and the need to handle vast volumes of unstructured and real-time data, SQL has found its limits. This opened the door for alternative database paradigms to rise in prominence. So the question here, what are the SQL's adversaries? What are they? First, we have the NoSQL databases, and NoSQL stands for not only SQL. The key players here, we have MongoDB, Cassandra, Couchbase, Redis, and more. The strengths of these technology of NoSQL databases, actually first they were created to address some of the SQL limitations. They are particularly good at handling large-scale unstructured data and can offer flexibility in schema design. Instead of rigid table structures, NoSQL databases can store data in document-oriented like JSON-like formats in the form of graphs also, or key value pairs. This makes them excellent for use cases like real-time analytics, IoT, and big data. Now, when to use these technologies? So when the application requires high availability, scaling, and flexibility in data structures, for example, content management systems, recommendation engines, and IoT applications are a good use of this kind of technology. And the second competitor of SQL is the new SQL databases. Key players are Cockroach Database, Google Spanner, TiDB. Their strengths of this kind of technology, then we're talking about the new SQL databases, aim to combine the scalability of NoSQL with the ACID guarantees of transactional SQL. These systems offer horizontal scaling while maintaining strong consistency, making them ideal for applications needing large-scale data with strong transactional guarantees. Best use of these technologies when scalability is key, but transactional integrity must be preserved, like, for example, in the financial applications, e-commerce, and large-scale SaaS applications. The third competitor of SQL are the graph databases. Key players here we have Neo4j, ArangoDB, and Amazon Neptune. Strengths of this graph databases technology: they store data in a way that emphasizes the relationship between different data points. They are especially useful for applications like social networks, recommendation systems, and fraud detection, where understanding of the relationships between data points is very, very important and even crucial. Areas of use are when relationships between data are as important as the data itself, like for example, social media networks, fraud detection, recommendation engines are key areas of application of this kind of technology. Fourth, competitor, so we have the time series databases. Key players, for example, we have the InfluxDB, Prometheus, and Timescale DB. Pros of this technology: time series databases are optimized for handling data that are collected over time, like monitoring metrics, sensor data, financial ticks. They provide efficient storage and querying of time-stamped data, which is essential for real-time analytics and monitoring. They are mainly used when you need to track changes over time, or when you are working with metrics and time-stamped data, for example, like server monitoring, financial systems, Internet of Things devices, and so on. The last competitor of SQL, we have the cloud native databases. Key players here we have Amazon Aurora, we have Google BigQuery, and we have Azure Cosmos DB. Pros are the cloud native databases are designed to leverage the power of cloud computing, offering features like auto-scaling, serverless architecture, global distribution. These databases can handle petabyte scale data and are optimized for high availability and fault tolerance. An area of use when building cloud native applications that need to scale quickly and efficiently, like for example data warehouses, global web applications, and enterprise cloud solutions. These are key areas of application of this kind of technologies. Now, when SQL still shines, while these alternatives, have gained, traction, SQL still dominates in many traditional environments, particularly, for example, enterprise applications, CRM, ERP, and other large-scale enterprise applications still rely on SQL databases. Data warehousing, for example, also. SQL databases like Snowflake, BigQuery are optimized for querying massive data sets efficiently. We have also legacy systems. Many industries have decades-old systems that still run SQL-based databases, making migration to alternatives very complex and costly. SQL continues to evolve, and with modern extensions like JSON support and window function, it still remains relevant in today's data landscape. As a data engineer or aspiring, junior data engineer, you cannot neglect the mastery of SQL as a language and the SQL solutions and technology. However, for specific use cases, like for example, especially those involving large-scale unstructured or real-time data, the adversaries of SQL, like NoSQL, new SQL, specialized databases, offer compelling alternatives. In the end, choosing the right tool depends on your specific application needs. SQL remains a powerful and reliable option, but its competitors provide valuable solutions for handling the new data challenges today. If you like this video, you can like it, you can subscribe. I would appreciate it, and we'll catch up with you in the next video. Thanks.